this is the second example for fractions multiplications. We did one last time with whole fraction. This time it's fraction times fractions. And you say going what direction again? Down to 3 and over to 2/5. But because they're fraction, we need to go to the next whole number. So essentially, we're going down to 1, going over to 1. Alright, so we're going to draw, look like a number line, starting from 0, go down to 1, and then go over to 1. After we have 1 and 1, we will... I'm going to go ahead and connect the box first. So this is 1 by 1. And then I need to go down to 3, 4. So between 0 to 1, I need to cut it into how many equal parts? So it's going to be 1/2. This half is 4. So that would be 1, 4, 2, 4, 3, 4, right? And then 1. And then horizontally, I need to reach 2/5, meaning I need to cut them into how many equal parts? So 5 equal parts. So it's going to be, as you can, hopefully they're about evenly spaced. So that would give me 1/5, 2/5, 3/5, 4/5, right? And all the marking, I need to do what? Connect all the lines, just like extend them to the other side. Horizontally, so hopefully they are equal size pieces. So, and then I need to color down to 3/4. Gonna circle it, and over to 2/5. So I'm gonna need to color down there to 3/4 and over to 2/5, right? Something like that. And then once I have that, how do I find the answer? Go to shaded part on top. Or what is one whole and what do we mean by whole? 1 by 1. So I'm going to highlight down to 1 and over to 1. Okay, so I need to count how many shaded part we have, which is 6 shaded part. 1, 2, 3, 4, 5, 6. 6 shaded part, and then count how many little boxes to make 1 by 1. So 4 times 5 is 20, you're correct. So do I need to convert this? Oh, this is a proper fraction, right? The top is smaller than the bottom, but we need to simplify by 2. They're even number, both top and bottom can be divided by 2. I do want you to write that out. So the answer is 3/10. Are we okay? And we can see that if you just do it by hand to check, 2 times 3 is 6 on top, 4 times 5 is 20 at the bottom, you reduce, right? Top times top, bottom times bottom, right? Any question on number 2, the second example for multiplication with rectangular area model? For the next one, this one would be the more difficult one because I'm going to do a mixed fraction times another mixed fractions. 1 and 2/3 times 2 and 3/4 using rectangular area model. This means I go what direction to what direction? Down and over. This is 1 and 2/3 over to 2 and 3/4. Essentially, I need to go to the next whole number. So I'm going down to 2 and over to 3. This is an example of a mixed fraction times some mixed fractions. What do I draw? From 0 to 2 down, over 1, 2, 3. And then what? All the marking horizontally and vertically. So we should have at this moment 6 boxes because it's 2 times 3. And then go down. I need to cut it to 1 and 2/3. 3 equal part between 1 and 2. So I'm going to cut that into 3 equal parts. So this one would be what? 1/3 and 1 and 2/3. Is that all? I have to do the same between 0 and 1 because otherwise they're not equal size pieces, right? So between 0 and 1, I also need to cut them into 3 equal parts. So, and then write them as 1/3, 2/3. Thank you. Now, how do I find 2 and 3/4? This is going to be between 2 and 3, cut it into 4 equal parts. Cutting. So half here and then half more. And say this is 2 and 1 4, 2 and 2 4, 2 and 3 4, like that, right? To do the same for the between 0 and 1 and 1 and 2, right? Everything need to cut to 4 equal parts. So I'm not going to label all of them. It's going to be too much, but you get the idea. Part between 0 and 1, 4 equal part between 1 and 2, 4 equal part between 2 and 3. Color down to 1 and 2/3. I'm going to circle that. Make sure you go to the correct place. And then over 2 2 3 4, which is here, right? It would be helpful if you have like color pencil, but don't draw it too small, so it's going to be hard to see how many boxes you have. So I'm going to color down to 1 and 2/3, over to 2 and 3/4. To color in, like if you don't want to count by hand, you can say 1 2 3 4 5 down, and 2 4 6 8 10 11. Say the part over one by one, right? So we shaded down 5 over 11, mean I have how many shaded parts? 5 over 11. 55 shaded parts. How many make one whole? I'm going to highlight from down 1 to over 1, right? So down 1, you need to highlight it. Over 1, like this. I can see the 1 by 1 hole is going to represent by how many little boxes? 12. This time we're going to need to do what? We need to convert. So I'm going to convert this. Which number go in the house? 55 divided by 12 is 12 times 48. What do we do between these two numbers? Subtract. Write down subtraction. Subtract, we get 7. My 4 is my whole number. Today is the first time I'm doing it. I'm going to spell it out. Whole number. 7 is numerator. 12 is denominator. So when I write the answer, the final answer is and 7 12. Question for this. Question for this. Okay, the next one is divisions. We are really simplifying a lot of the contents, just the bare minimum that we require you to know. We didn't show you as much as last semester. If you need to see more, you can go on D12 to watch that. When we do divisions in the regular world, how do we divide fractions? We need to change division to multiplication, and then flip which one? Second term. So that become 2/5 and multiply 11 over 6. So when you multiply fractions, you multiply top times top, bottom times bottom, right? 22 over 30 and reduce it, we get 2 are at 11 over 15. One of the question is, why does this work? So we want to be able to prove it to you, this work. Some of the schools say don't need to know why inverse and multiply, so that's not a very good way to teach anything. They want us to show you the proof by using complex fractions. When we have a fraction divided by another fraction, we can use a division line to represent this division sign, like this here. So we're gonna have which fraction on top is the division line, then which one go to the top? 2/5. Which one go to the bottom? 6/11. Okay. So once we have that, if I want to get rid of the denominator, we want to get the denominator equal to 1. Multiply the reciprocal of the bottom number. To do that for both top and bottom. Alright, so reciprocal means what? This fraction. So if you flip it, what do we get? 11 over 6. Whatever you multiply at the bottom, do the same on top. So this will reduce this 6 with this 6, 11 over 11. When you multiply fraction with fraction, anything on top with anything at the bottom. So now you're going to have something like what we see earlier, the 2/5 times 11 over 6 over 1. When you have 1 as your denominator, what does that mean? We have to write that? No. So this equal to 2/5 multiplied to 11/6. And then at the beginning, we have 2/5 divided by 6/11, right? So it's changing it to multiplication and flipping it. So they just want to prove it to you mathematically this is correct. That's all. I want us to show you how they come up with that. So there are many ways to show this. They can do the missing factor. We can do common denominator and multiply straight across. For this semester, we just focus on getting the common denominator, okay? So there are other strategies, but we don't want to confuse you too much, and plus this is the competence exam, so we narrow it down to these strategies we want to show you. This is considered division, fractions, doubt, invert, and multiply. We're going to use common denominator for this semester. We are doing 7 over 8 divided by 8 over 11. So at the end of last semester, we did do founding LCD or GCF. So hopefully you still remember how to find the lowest common denominator for these two numbers. We found lowest common denominator if the denominator is 8 and 11. Do you think they are? Denominator will be 88. So a lot of time if you just multiply these two will work. Sometimes it may not be the smallest number, but it will always work if you multiply them together. So if both of them are even, maybe you can find like a slightly smaller number, but this one you cannot. Okay, so if I want to get the first fractions, so the second fraction to have 88 as denominator, I don't want you to add step on the question, rewrite the questions, and do your step on the second step here. So what can I multiply to get to 88 from 8? It's 11 at the bottom. If I times something at the bottom, I need to do the same thing on top like that. Because if we reduce that, that's like multiplying to a 1. So that's a legal step. How about the second fraction? Multiply by 8 at the bottom, 8 on top, right? Again, whatever you multiply at the bottom, do the same on top, right? This will give me what? 77 over 88 divided by 64 over 88. Once you have the same denominator, you can divide straight across. We got 77 divided by 64 over 88 divided by 88. So now the bottom will be 1. The top will be a fraction of 77 over 64. So when you have 1 as denominator, then you can write this answer as 77 over 64. Can this be my answer? Because you need to convert it. The top is bigger, right? We call this what kind of fraction? Improper fraction. What go in the house? 77 need to be divided by 64. We need one whole. So subtracting 64 will give me 13. So 1 is my whole number. So I already wrote the word, right? So this is the second time we're doing it on the same page. So I abbreviate it to whole, and then 13 is my numerator, 64 is my denominator. So the final answer will be 1 and 13 over 64. So this is multiplications and divisions. So normally, why after this? But if you are interested in what is device rate course, I have video on detail out. Normally after this, we will do fractions work problem. We will hold on to this a little bit longer. We need to go into decimal first. So after we finish decimal, we're going to go back to this because I normally don't assign homework for the work problem. We do all of them together. So it gives me a little bit time to catch up with all the grading.